workforce training is very crucial in order to fully exploit benefits of silicon carbide. Do you think we're still lack of adequate talent cultivation in this area?
So silicon carbide, if you look at a few years back, the major applications was photovoltaic, and it was growing at a relatively predictable pace. Then all along comes the electric vehicle. So now there is this mass application where silicon carbide happens to bring a very distinctive advantage. So now you start seeing explosive growth, and certainly the training of the workforce has not kept up with the demand. Now, you do need to have a well-trained workforce to skillfully insert silicon carbide into systems in order to allow silicon carbide to operate to its full potential. So a lot of efforts have gone towards training the workforce, training students in order for this demand to be met. I've been leading PowerAmerica on the behalf of the US Department of Energy for the last 6 years. And during that time, I recognized that workforce training is a problem. In the end, if you don't have application engineers who are comfortable with inserting and using silicon carbide devices, they're not going to do that. And if they don't do that, then they will not create the demand that will lead to mass production. And if you don't have mass production, it will always be very expensive. You're not going to be able to compete with silicon if you don't have mass production levels. So what we did at PowerAmerica is over the last 6 years, we funded more than 110 projects where 2 full-time students or more were involved. So in the end, with all the students, full-time students involved in the projects, we trained 410 students over the last few years. And the idea is these students will graduate, they'll find themselves in the industry. Because they've worked with silicon carbide and understand how to use it, they're not going to be apprehensive in its use. They'll be able to insert it, and they'll be able to do it in a way that fully exploits its potential. Now, some of these students will go into academia. So they'll become professors and train other students. And the ones that do go into the workforce, they will train others. So I think we've created a seed with a snowball type of effect, an avalanche type of effect that will train more and more people. But being in this industry, I hear this all the time. People come to me seeking talent, and particularly in the United States, where the microelectronic industry, the microelectronic industry was born here in the United States, and eventually it migrated to Japan, and from Japan it went to South Korea, China, Taiwan, and so on and so forth. There is a lack of people who can do processing even of silicon. So when you try to bring in people to process silicon carbide, it's very hard to find these people and train them if you have to start from scratch versus people that are already trained in silicon. And I think that's one of the big advantages that countries in the Far East have when they try to make their transition from silicon to silicon carbide, that they have a workforce trained in the microelectronics industry that can easily be further trained and adopt to using silicon carbide. But certainly, what I can tell you for sure, if you take out a silicon device and throw in a silicon carbide device in its place, you will see very little benefit, if any. You'll just pay more money for the device. So you need to be well educated and understand how to make the silicon carbide circuit. So all the way from making the substrates, doing the epitaxy, fabricating the devices, doing the test and the inspection, to the very important circuit design and system insertion. Because in the end, you want to make a system with silicon carbide that will have advantages and outperform silicon. Without that, you don't have anything.